In this video, we're going to be talking about multiplying complex numbers. So just to recall, we know that I is equal to the square root of negative 1. So anytime we see the square root of negative 1, we actually are going to rewrite it with I. And then we know that when we square both sides of the equation, so I squared, we end up with a real number, negative 1. Let's talk about a few higher powers. If I cube it, well, I cubed is the same thing as I squared times I, right? And I squared, we said, was negative 1. So it becomes negative 1 times I. And negative 1 times I is just negative I. I to the fourth, well, that's just the same thing as I cubed times I. We just found out I cubed was negative I. So negative I times I would be negative I squared. But I squared is negative 1. So now we have a negative times negative 1, which gives us positive 1. And we're going to see that this kind of goes in a cycle. Because now, if I did I the fifth, I'd be multiplying 1 by I. And I'd just be back to I. So anytime that you see any powers of I, you need to rewrite it. You should actually only be getting these answers in your solutions. I, for if it's I the first power, I squared, we're going to rewrite as negative 1. I cubed is the same thing as negative I, and I the fourth is 1. So we need to know that whenever we're multiplying here, we can only get 4 answers with i's. So it's either I, negative 1, negative I, or 1. I shouldn't have any I squareds in my answers. I shouldn't have any I cubes, I to the fourths. These are the only 4 possibilities. Alright, let's go ahead and multiply. Negative 5i times 3i. This is all multiplication. Negative 5 times I times 3 times I. Multiplication is commutative. We can multiply in any order we want. So we do negative 5 times 3 and get negative 15. And then I times I would be I squared. But we said I squared was negative 1. And then negative 15 times a negative 1 is positive 15. If I have one term times a binomial or polynomial, I'm just going to distribute. So negative 2i times 6, we do negative 2 times 6 and get negative 12 times I. Then negative 2 times a negative 2 would be positive 4, and I times I is I squared. Again, I'm never going to leave an I squared as part of my answer. I'm going to change that. So negative 12i plus 4 times I squared is negative 1. And then we simplify. And in general, you're going to want to write your answers in the form a plus bi. So you want to write the real number part first. Most of the time, directions will ask for that. So I'm going to start with 4 times negative 1 is negative 4. And then minus that 12i. A plus bi, the real number part plus the imaginary part. Now what happens when I have 2 terms multiplied by 2 terms? I need to either box or FOIL that out. Again, as you know, I'm a fan of the box method for multiplying. So I'm going to go ahead and do that, but you're more than welcome to use FOIL if you're comfortable with that, or just distributing. So 3 minus 4i goes on one side, and 6 plus I goes on another side. Then we multiply the boxes together. 3 times 6 is 18. 3 times I is just 3i. Negative 4i times 6 would be negative 24i. And negative 4i times I is negative 4i squared. And I need to simplify all this. So I have my 18 first. And then these are like terms. 3i plus a negative 24i. Well, I can add those. 3 plus negative 24 would be negative 21i. And then that negative 4i squared is negative 1. We don't leave the I squared in our solution. We change it to negative 1. I'm going to go ahead and multiply those two. And negative 4 times negative 1 is a positive 4. And lastly, I need to combine my constants, my real number part. 18 plus 4 is 22 minus 21i. Why don't you go ahead and try the next two? And remember, you cannot distribute an exponent across a sum or difference. You need to multiply that whole quantity times itself. Alright, part D. I have 1 minus 2i squared. That means I'm going to multiply it by itself, right? And you can box or FOIL it. It's a poor box, but I'll go with it. 1 minus 2i, 1 minus 2i, multiplying it by itself. 1 times 1 is 1. 1 times negative 2i is negative 2i. Same thing down here. 1 times negative 2i is negative 2i. And then negative 2i times negative 2i is a positive 4i squared. Alright, rewrite that. So I have 1, and then on that diagonal, negative 2i plus negative 2i would be negative 4i plus 4 times negative 1, right? I squared is the same thing as negative 1. And if you've noticed, that I squared just changes the sign of whatever it's being multiplied to. If this was a positive 4, now it's going to become a negative 4. So now I have 1 plus a negative 4, which will be negative 3 minus 4i. And that's a negative. Alright. And now part E. Again, I'm going to box it out. I have 6 plus 5i times 6 minus 5i. 6 times 6 is 36. 6 times a negative 5i is negative 30i. And 6 times positive 5i is positive 30i. And 5i times a negative 5i would be negative 25i squared. So now I have 36 plus and minus 30i, that's 0. So minus 25 and I squared is negative 1. So now I have 36 plus 25, and I end up with a positive 61. Notice what we were multiplying. Do you see a relationship between what we were multiplying? If you did, you'd notice they are conjugates. Okay, so the exact same terms, but the sign in the middle is different. I have one positive and one negative. And again, when we multiply conjugates, the middle terms drop out, and we're left with a difference of squares. Only in this case, because I have this difference, so there's the subtraction, but the I squared makes it a negative 1, which changes it to a positive, so it ends up being a sum of those two coefficients squared. And notice my answer doesn't have any i's at all. It's just a real number. So we're going to use that in the next video.